And, well,
Thank you, Christian. That makes me feel good. Number one, on the OGT stuff, follow along. Make sure that you are following along. Noriko knows that angle 1, angle 2 are complementary angles. So angle 1 is complementary to angle 2. What's complementary mean? Add up to 90. Good. They also tell us that Noriko, that she knows that angle 1 is complementary to angle 3. I'm supposed to be using my pen here. Let's forget. So,
are you saying after today? I don't know if I'm going up there.
angle 1's complementary to angle 2. Angle 1's complementary to angle 3. We had a theorem. What's the theorem say again? If you got two angles and they're complementary to the same angle, then these two angles have to be what to each other? Congruent. So if you wrote this, if, well, probably should write true first. If two angles complementary to the same angle, then they must be congruent. If you wrote that, that would be good enough for what they wanted. Number 2. Guarantee you see this problem again. Hint, hint.
It's on the test.
Yeah. Say that last word again.
Test.
Put a plural on it.
Test.
You'll see it at least 3 times this year. You'll see it on the chapter 3 test. You'll see it on the semester exam. You'll see it on the final exam. I don't know how many lines they got in there. Don't know. All right, they give you something that looks like that, and then my picture looks spectacular. I'm not worried about that. They tell us that this is angle 1, this is angle 9. What do you know about angle 1 and angle 9? They're congruent because what kind of angles are they? Vertical. Good. All right, so the vertical angles, we can use all that stuff. Let's see, 2, 8, 3, 7, 4, 6, 5, and I'm not going to read the whole problem. Let's see which frame is it. They want to know which statement is always true. They give us a few things there. It says angle 5 is congruent to angle 6. Look at where angle 5 and angle 6 are. Are they going to be congruent to each other? What are 5 and 6 to each other? Supplementary. How about B says angle 6 is congruent to angle 1. 6 and 1. They gonna be congruent? This is part of what you should have done on your homework last night. If I look at angle 6, it goes like this. Angle 1's over here. Split that stuff off. 6 and 1, anything special to each other? The alternate interior angles, alternate exterior angles, corresponding angles, any of that stuff? Jason, they any of those to each other? I'm gonna start calling on people since you guys aren't answering questions. 6 and 1, they anything special?
No.
No. Are they gonna be congruent to each other? No. Next one, everybody paying attention because I'm gonna call on somebody. I'm not asking free questions anymore. Angle 7, angle 8. 7, angle 8. Sierra, 7 and 8 congruent to each other?
No.
No, what are they?
The button one and that.
Adjacent, that's true.
Yeah.
What else? Will they add up to equal?
180.
180. Let's hope that the last one's right, because that's the only one's left. 9 and 3, what kind of angles are 9 and 3 to each other? Christian, what kind of angles are 9 and 3 to each other? If I trace them, they form a what? A Z. Alternate interior angles. What do we know about alternate interior angles? They're always what to each other? What is it, Jason? Congruent. So our answer on that one would be D. Number 3, find the perimeter of that triangle. Kaylee, help me out here in a second, as soon as I get done doing this, so that you can tell me the coordinates, so I don't have to keep looking back at my book. Try to draw a decent graph this time, so maybe it'll look right. Alright, what's the first coordinate?
J is -2, -1.
-2, -1.
And then K is -2, -3.
-2, -3. Put my thing in the wrong spot. Now what?
And then L is 5 and -1.
5, -1. So it is a right triangle because this side is horizontal, this side is vertical. How can we find the length of this side? What do you got to do to find the length of a horizontal line? Just count. So how far is it, Taylor, how far is it from, the -1s are the same, so we don't have to worry about that. How far is it from -2 to 5? This one, same idea, only we don't worry about the -2s. Bailey, how far is it from -1 to -3? Now, you could use Pythagorean's theorem. I'm not going to use Pythagorean's theorem because I know what we're going to cover today. And I want to use the distance formula because you're going to have to use the distance formula today. So to find this third side, I'm going to use the distance formula. Remember the distance formula, you subtract the x's, square it, subtract the y's, square that answer. And you should have the little 1s and 2s in there, it doesn't really matter. As long as you know that you have 2 different x's, 2 different y's. Natalie, what's our x coordinates for points K and L? So I'm going to do 5 minus, make sure you watch your signs, a -2. Alexis, what's the y coordinates for K and L?
-3, -1.
Now, unlike the slope formula that we've been doing, Natalie started up here and went this way. Alexis started here and went that way. With the distance formula, does that matter? No. If we were doing slope, then you got to make sure you take them in the same order. So we got -3 minus a -1 squared. Change the sign there. Christian, 5 plus 2 is what?
7.
That's too easy. So now square it for me.
49.
Kaylee, -3 plus 1 is what? Close. -2, square that. Be careful. 4. 49 plus 4. Taylor, what's 49 plus 4?
53.
53 are perfect square numbers here? No. But I don't have a calculator up here. I don't want to use the calculator. So what I could do, if you don't know what it is, you know it's between 49 and what's the next higher perfect square number? After, that goes past 53, after 49. That's 7 times 7, right? What is it? Not 54. 64, right? 8 times 8. Which one's it closer to? 49 or 64? All right, so it's probably falling somewhere about in here, right? So if I had to guess, I'd say, it's not too far past 7, but it's a little past 7. It's not quite halfway because we're at 53. So if I had to estimate 4.2 or 7.2, 7.3, somewhere around there maybe, wouldn't be quite to 7.5 because it's not halfway. So we'll say 7.3 since Taylor told us what it was. How do I find the perimeter of that then?
That's what I forgot to do. I forgot to put the perimeter. And then I forgot something.
How do you find the perimeter?
Yeah, well, then.
Add them all up. 7 plus 2 plus 2 plus 7.3. That gives us 0.3 plus 16.3. That's your perimeter.
Yeah, I did all that. Besides, I didn't add the whole thing.
So that means 3 of us missed it.
So make sure you remember the distance formula. We are going to use that today. Next one, what's next? 5. Number 5. Everybody follow along, look at that chart. We're just going to go around the room. On number 5, we're going to start with Christian, Natalie, Taylor, Jason, so on and so on. Tell me the lowest so I can write them all out in order up here. So looking through that chart, Christian's going to tell me the lowest number. Then Natalie's going to tell me the next lowest number, so on and so on, all the way around the room. And then we run out, we'll start all back over. So Christian, what's the lowest? Yes. Yes. Sure. Right after he answers this question. No. What is it? 19,850.
I don't understand what we're doing.
You tell me we're making the list so I can write them out from smallest to largest.
For what?
Because you got to find the mean, median, and mode.
I thought we're doing. I thought this is homework.
No, it's the OGT stuff.
Alright,
Natalie, what's next? Say it one more time. 20,800? Oh, 100. All right. I don't want to put commas in there. That's going to confuse everything. Next one.
That's not the highest. What Christian would do?
That's the lowest.
Oh my god, I'm so confused.
We're going from lowest to highest. Next one. Tell me, Taylor. After 20,100.
25,350.
25,350?
I have this broke down on my paper. You just want to get my paper.
Nah, you'll be fine. This is working. Tell me next one, Jason. Keep putting commas in there.
26,500.
Next one, Alexis.
28,500.
Next one, Kayla.
600.
Next one, Bailey.
29,500.
Next one, Natalie.
No, it's 31,200.
Oh. I can't tell. I took a picture of my paper. I can't
Next one, Natalie.
tell.
32,000 even. Next one, Taylor.
3,600.
What is it?
3,600.
3,600. 36,000.
It's not 800. It's 36. Like
36,000.
36 from 000. 3,600.
36,000.
That's what she said. What time?
No, she said 3,600 all 4 times.
Oh, okay.
That's why I couldn't understand what she was saying. Next one, Jason.
38,500.
Next one, Alexis.
85,000.
I wish I made that much money.
Is that it? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Should there be 12 of them?
Yeah.
All right, so we have them all. So let's just go down through here. We can find the mode. We can find the median very, very quickly once we make the list. What's the mode? No mode because none of them appear more than once.
We done the mean, yeah.
So, yeah,
Should we do that before we cross everything out?
median. I don't cross everything out when I do it. So some of you, what Jason's saying, you go through and you cross them out. I don't do that. If there's 12 of them, what's half of 12? 6. So I go 1, 2, 3, 4, 5, 6. I'm right here. 1, 2, 3, 4, 5, 6. I'm right here. So is there an actual median this time? No. So what you have to do is add these two up, divide by 2. So 28,600 plus 29,500. 17, 18, 58. Divide that by 2. That's going to give us what? 29,050. Now the mean. How do you find the mean?
Add them all up and divide by however many there are.
Add them all up, divide by how many there are. See if I can add all this up in my head. Anybody got it added up there?
Not anymore now.
I had it. I had it in my paper.
Yeah.
Let's see.
Well, there's an inappropriate word on your bar track thing. I can see it. That is a bad word.
No. 123,000. 159,000. 187,000. 215. 244. 275. 301. 326. 346. And 365. 365,000. Now if I add up all the, it's 5,000, 2,100, 2,300, 2,800, 2,900, and that'd be 40,
It's 33.
41, and 4,100. No number there. 0, 0, 1, 9, 3, 6. That look right? 369,100.
Hold on, it's the calculator.
Huh?
Take the calculator.
Because I know it's right. Divide by 12.
Oh, here, it's not right. The mean is 33.
Really?
On my calculator, I put it all in.
So what'd you get?
It's 33,425.
No, I add them all up. I haven't found the mean yet. And that's not right?
No,
What did you get when you add them all up?
dang it, I just took 2.
Because I don't believe you.
Take my calculator, 'cause I'm not getting up.
Divide by 3, it's 36. 9, won't go in there, get 30,000. I'm not gonna go any farther than that because we don't need to. Now, what they ask you to do, you're going in and ask your boss for a raise. All right? And you decide what they say that you want to use. The median? Is that a good idea? What most of you put?
The mean.
Use the mean. If you're going in and asking for a raise, and you say the average person makes 30,000, it's actually more than 30,000. Is that going to be as good as using the median? What do you want to tell your boss if you're asking for a raise? You want the higher number or the lower number? If you're asking for a raise, you want the lower one because that makes it look like all of you don't earn as much. And you say, hey, we need a raise because the average person here only makes about $29,000. If you go in there and you tell them the average person makes $30-some thousand, it doesn't look as good. All right? So don't always assume that the mean is the best thing just because that's what you've always used to figure out your grades and everything else. All right?
And why do they use that to figure out our grades?
I have no
I
idea.
got completely different totals.
That's why I don't. That's why my stuff's all weighted and I do it different ways than other teachers.
I had a different mean.
Yeah, because you was wrong. I did it twice.
What's that wrong? So it's 33,000 something? Still doesn't matter if it's 33,000. Do you really want to use that?
Yes.
No, because then your boss is going to say, "Oh, you guys make $33,000. I ain't giving you no raise. Everybody makes plenty of money." Well, does everybody make $33,000?
No.
No, you got some of these poor people. This person here only makes 19,000. All right.
Morgan 20.
So don't always just assume that the mean is the best one.
I blame taxes. Obama.
Next one. What was next? 6. This is what we're going to cover today, so listen carefully. How is the shortest distance between a line and a point? And we actually talked a little about this last class, sort of. One of the theorems talked about it. If I'm going to find the distance from this line to that point. So this is Jason out here. He's out in the desert.
Hey, what up?
And this is a road. The line's a road. We need to get Jason to the road as quickly as possible before he dies of thirst. So when Jason's got his cell phone and I'm telling him which direction to go on my cell phone,
Mine says that.
and I'm probably telling him to go that route, correct? I'm telling him that route, right? Why not? It's too long. All right, so he would probably die in between here and there. How do you want to tell him to go?
Straight.
It's plot.
That was straight.
It's not straight.
That is too straight.
Go.
You want to go so that it forms a what?
Northwest.
You want it to form a what when it gets to the road?
Perpendicular.
Perpendicular. All right. So that would be the shortest distance.
Wait a minute, hold on. Which line's the road? The line or the arrow line?
This one. This whole thing is the road. So you want it anytime you're trying to find the distance from a point to a line or the distance between two lines, you always want something that goes perpendicular to them. You don't want something out here. It's not going to be the shortest possible distance or something out here. It's got to form a right angle there. Shortest distance is always going to be something that's perpendicular. And number 7. Number 7, the slope they told us was -1/2, and they gave us this point. What's the equation for the line in slope-intercept form? What do I put in place of m? -1/2. And they actually tried to confuse you. This is your y-intercept because that right there is 0. They tried to confuse you in what they do with the two terms. They flip them around. That doesn't make any difference, so. All right, open up your books to page 155. You too, Taylor.
Huh?
Open up your book, 155. No, you weren't. Questions?
Dude,
Yes.
because that's all I found on Google.
Yeah, it's got all the logo on it.
27.
You might want to get it off somebody that, you can use the whole bunch, but you might want to get the picture.
27.
Problem 27. Can you guys see that, or do I need to switch the color again?
Well, it seems pretty noticeable.
Okay. Problem 27 gives you these two lines. They want it to be they want you to find X so that L and M are parallel. And 8x plus 4 is that angle, and this angle is 9x minus 11. Tell me what kind of angles those are. Sierra, what kind of angles are those? What special name do we give them? That's true. Tell me what they are in relationship to the two lines that we want to be parallel. Alternate exterior. Does everybody see that? You guys are acting like you've never seen any of this stuff before. Those are alternate exterior angles. You got to know this stuff. We got a test coming up. Might be next class if we keep going the way we're going now, so it might be Friday. So, alternate exterior angles. Somebody look up that theorem. What's the theorem say about alternate exterior angles? The lines are parallel. What do you know about alternate exterior angles?
They're congruent.
They are congruent. So what equation can I set up from this? 8x plus 4 has to equal 9x minus 11. Take just a minute, solve that. Shouldn't take you more than a minute. Write it down on your paper there. Everybody should be writing. Solve that equation. Figure out what x is. There you go. No more pencils at school for me.
No, I got it from home.
Good problem. What's x equal? Say it again. That sounds right.
Sounds about wrong.
So what did you guys come up with? What do I do to solve it? Tell me that, and we'll solve it.
Minus 4.
Before that,
Oh, yeah.
get all the x's together first. That'll make it easier.
That's what I was doing wrong, because I did the non-x's. I had the one that wasn't.
So what do we do to get all the x's together? Subtract 8 x's. Where a lot of you make mistakes, if you don't get all the x's on one side first, it's not wrong, but it makes the problem a little more difficult, makes it harder to understand. Now what do I do? How do I get x by itself? That's all they wanted, right? X equals 15. You said 15, is that what you said? I didn't hear you. 30. Which one? 30? Problem 30. Problem 30. What kind of angles are those two to each other? Natalie, what kind of angles are those two to each other? Give me the special name.
Why don't we do that?
So let's look at the picture again. Let's go through this real quickly. Everybody watching? I'm going to ask everybody questions. I'm not sure why I put a 6 there, and
1, 2, 3.
doesn't
6.
matter. 1, 2, 3, 6, 4, 5, 7, 8. Just confused myself.
Okay.
If we have these angles, looking at those angles, 1 and 8. What kind of angles are 1 and 8, Caleb?
Oh.
Alternate exterior angles. What do we know about alternate exterior angles, Bailey? If these two lines are parallel. Don't listen to him.
Say no.
All of them are the same thing except for the one. He's giving you the right idea, but he confused you. What's the other word that starts with that? They're congruent. So 1 and 8. I'm hoping you guys are listening because you got to know this for this test. Alternate exterior angles have to be congruent. 3 and 5. Sierra, what kind of angles are 3 and 5? Alternate interior angles. Good. Jason, what do you know about alternate interior angles? They have to be congruent also. Alexis, what kind of angles are 1 and 4? Corresponding angles. Remember, with corresponding angles, you shove the two lines together and they overlap each other. Christian, what do you know about 1 and 4? They have to be what to each other? They're corresponding angles, so they have to be what? Congruent. And the last pair, the one that confuses everybody, Natalie, so you're ready, right? 3 and 6, or 3 and 4, sorry. What kind of angles are 3 and 4 to each other? Consecutive interior angles. Consecutive interior angles are different than all the rest. So Taylor, what do we know about angle 3 and angle 4? They have to be what to each other? I don't hear that answer, so look it up or something real quick. 3 and 4.
I don't have my notes. She's.
Well, I don't think
Can you use your book.
Yeah.
Consecutive interior angles. If these lines are parallel, it's not what everybody else has said the whole time. They have to be what to each other? It's the only one that's different than all the rest. Look at those theorems that we had last time. That's
Start
what
with
it'll
an
tell you.
S.
Yeah, it starts with an S.
They're
in the book.
I don't know what.
Sub.
So we were on page 155. So turn back a page or two from 155 and it'll be right there. Big yellow box. Now that's the lines. Lines are parallel.
You did the practice problems, it's in there too.
You think that they're all parallel though?
The lines are parallel. The angles are what to each other? 3 and 4, consecutive interior angles. Supplementary. That's the only ones that are different, so what do we need to know about 3 and 4? What would we have to do with 3 and 4? They should add up to be 180. Looking at our angles, back to our angles. What are they? Alternate exterior angles. What did we just say about alternate exterior angles?
Congruent.
They're congruent. So tell me what equation I should be able to set up right here.
5x plus 90 equals 14x plus 9.
No, we did the one that Jason, and he asked me for both of them, and they were both basically the same
Yeah, I
problem.
realized that when I said it. Because
Oh, we did it together?
There was another one.
I don't
remember.
Had the exact same thing as that?
Yeah, it equals 9.
It adds up to be 9, or
Oh, it
x equals
does.
9. Now, I bet on the one on 154, were they alternate exterior angles? I bet they were also. I bet they were alternate interior angles or corresponding angles. Corresponding. So they just kept the numbers the same but changed the locations. Other questions? So make sure you know those. I'm going over them. First of all, no notes on this test. None. So you got to know alternate interior angles are what to each other? Congruent. Alternate exterior angles are congruent. Corresponding angles are congruent. Then the one that's all by itself, sort of, consecutive interior angles are supplementary. You got to know that stuff.
So pretty much the only ones that were supplementary, everything else is congruent.
Right.
But the ones that inside.
The ones that are,
But
well, you don't want to say buddy because you told me a little while ago that buddy was the adjacent ones. And I don't want you to get those confused.
oh, I won't remember it.
It's right here. It's the two that are inside that there's nothing in between. All right, it's like they're right there together, consecutive interior angles. All right, today is what's today?
Oh.
Today's the 13th.
No, this is.
You've done them. Quit messing with. So today is the 13th. Go ahead and copy this down. Not sure why it's not playing now, Jason, but I'm not messing with it anymore. That's what they get, and I'm going to end up switching it again and have to figure it out again. All right, go ahead and write this down. Distance between a point and a line or two lines is always a segment that is perpendicular to the line or lines. So that's what I just said on the other one. If we have
Crazy.
never works, right? If I draw this, if I have a line and some point not on the line, the shortest distance always has to go perpendicular to that line. If I have two lines, it's got to be perpendicular to both of them. That's going to be the shortest distance. have to form right angles with either the one line, if you're going from a point, or both lines, if you're going between two parallel lines. And again, they have to be parallel lines. If they weren't parallel lines, if I have two lines like this, what's the shortest distance between those two lines? What's the shortest distance between these two lines? Is it going to be something out here? Where's the shortest distance going to be? When they go on up here and they do what? They intersect. It's going to be 0. Alright, so that's why the lines have to be parallel to each other. Alright, so if I'm looking at this, again, this is what I just drew up there. These have to be right angles. The dotted lines that I have on here wouldn't be the shortest path. We want to go right angle to the line. Alright, this is your assignment. We're going to work some of these together, so get out a sheet of paper. We got about 8 minutes. I hope we have a little more time than that. Should still be enough to do a few of them.
Is there a ruler?
Yep. Turn to page 162. Everybody get out a sheet of paper. That way I can get started right away. We can start working on them. Problem number 4. They give us a shape that looks like that. Bailey's going to go up there. I'll do the hard part for you. We want to go from L, so she's going to go up there and she's going to grab my pen. She's going to put her pen on L. And she wants to draw the shortest path from L to line KN. Do you see where KN is? So she wants to draw the shortest path in that. Perfect. Now, to make sure that we know it's the shortest path, what are you going to put down there at the bottom? What should she put down there in that bottom corner? That's a little square, a right angle symbol. Perfect. Number 5. See how smart everybody is. Be looking at number 5 because I'm getting ready to call on somebody again. This one's a little more difficult. Gotta make sure I got the right shape. What is that? A pentagon?
Yeah.
I can sort of draw it. And somebody help me out so I don't have to keep
Wait,
looking.
number 4 is behind
That's it. You want to find that shortest path. Somebody tell me what's this top corner on number 5? Does it go around it somehow?
That's B.
B? This A? I'm guessing that's D and E.
Yep.
They want us to draw the shortest path from D to segment AE. Got a volunteer before I call on somebody? Oh, you guys gonna make me call on somebody? Is everybody too scared? What do you got on paper? Huh? Some over there. All right, Kaylee, you're the closest. Kaylee's going to go up there. She's going to put her pin, or put my pin, on point D. Now, we want line AE. So you want the shortest distance to line AE. Use your imagination a little bit. Now, we said the shortest distance is always going to be what? Perpendicular. So, how's it got to go? It's confusing, isn't it? Remember back with triangles, sometimes, don't go away. Sometimes with triangles, if you have a triangle that maybe looks like this, and they wanted to tell you the height of that triangle, where did it fall at? Right here?
No.
Where did it fall at?
Yeah.
So, look at what I did, Kayla. See that? That's what you want to do there. So from D, how's your thing going to fall?
So I gotta go over and under?
No, you're going to go... Okay, hang on.
On the outside.
It's on the outside. I had a piece of string. So start at D, and you're going to go straight down towards the ground. No, that's not straight. There you go.
Wow. Nice arrow.
So with this, come straight down. What do you have to do to that side? Make it longer. Extend it out. All right? Extend it out. Flip over to number 22. I know this is out of order, but I want to start on number 22 so you can at least see it, so you can have an idea. You might want to grab some graph paper before you go. It says find the distance between each pair of parallel lines. What I suggest you do is graph each line. Remember, when you're graphing them, the first one says y equals 4x. What's the y-intercept for that 4x? What's the y-intercept for the 4x there? Doesn't have one, does it? So what do you put in there? 0. So that means it's going to cross the y-axis right there at that point. What's this slope tell us to do? 4 over 1 tells you to do what? Up 4 to the right 1, up 4 to the right 1, up 4 to the right 1. What if you run out of space going that way?
And go down one and the right one.
So that's our first line. Draw in the other line. And then you want to find this distance. Well, what you're going to have to do is find 2 points that fall on each of the lines to find the distance.
I got this. Come up with numbers like this.
So, you stupid thing.
You said we were doing 22.
Josh?
Yeah, 22.
I hate that song.
Is this real life? Is this just fantasy?
I'm going to draw this way up here.
Escape from reality.
This is my x-axis. Don't need anything special for the y, so I'm going to put it somewhere in the middle. If I could hit the lines. Somebody tell me how to graph this. Let's do the second one first. How do I start to graph that? Where do I start at? 3, 6, 9, 10, 11, 12, 13, 14, 15, 16, 17. Put it right on the y-axis. Everybody watching, making sure, because this is probably the hardest thing we've done all year.
What?
Negative 17. What's the slope? Tell me it did. Up 4 to the right 1. So another point right there. Up 4 to the right 1. Up 4 to the right 1. Up 1, 2, 3, 4 to the right 1. You can keep going forever. 1, 2, 3, 4 to the right 1. I'm going to stop there. Try to draw in this line if I could hit any of those points maybe.
That looks like a parabola.
Ooh.
It's a good thing you know big words, Brian, but that doesn't look anything like a parabola.
Well, I mean, it's like the
It's
side
like,
of a
it goes like
parabola.
that.
The next line,
You screen.
4x. How am I going to graph this 4x? Start at 0, 0, so that's right there.
Then go up 4.
Oh, you got
Up 4, right 1. Now, I'm going to run out of space going that way, so down 4, left 1. What should be true about these two lines? They're parallel to each other.
Wait, why do you go over 1? So it's 4 over 1?
Yeah, it's like having a 1 underneath there.
So
we have those two lines. What we need is we need to figure out the line that's perpendicular in here. All right? Several ways you can do this. You could pick a point on here and know that the slope of any line perpendicular to that one has to be the opposite reciprocal. So what's the slope of a line that runs through here and forms a right angle? All right, so it'd be, if we take the 4 over 1, we flip it over, and we take the opposite, it'd be negative 1 over 4. That'd be the slope of this line, negative 1 over 4. So if we do that, we know the slope of a line that's perpendicular to this is negative 1/4. This is probably the easiest way, and since I know we're going to run out of time, this is what I'm going to show you. You find that slope that's perpendicular, negative 1 over 4. That's the line that's perpendicular to it. And then you just pick a point on this. A lot of times I'll pick this point because it's easy, 0, 0 especially. And I want my other line, my perpendicular line, I'm going to change colors here. I want my perpendicular line to start there. And I'm going to go down 1 and to the right 4. Down 1 to the right 4. So I draw in this line.
You're there.
That's our perpendicular. Now what we actually want to find is the length of that line. Once we've done all this work, how am I going to find the length of that line? Use the distance formula. So now I use the distance formula.
So much stuff.
I know that that's 0, 0. I got to find those coordinates. What's the coordinates of that other green point? 4, negative 1. Good. And I plug it in. Now this is going to make it nice using 0, 0 because now if I do 4 minus 0, everybody can do that math hopefully. Negative 1 minus 0. That's a negative 1 there. You can't see it because it's on there. What is 4 minus 0? Squared. 16. Negative 1 minus 0. 16 plus 2. That's 18. Now to find that length, all you got to do, square root of 18. I don't have a calculator, but I know square root of 16 is 4, right? So 4 point, let's see, go 16, 25 is the next one. 18 is pretty close to 16, a little farther away. 4.3, 4.2, I would say.
4.3, 2.
Is it 2? That would be your answer. That's the distance between those two lines.
2.
What 2? This 2?
Yeah. You square 1.
Wow, that's 1. Somebody lied to me and I wasn't listening.
Oh, no, Corbin.
Corbin, you lied to me. You told me 1 squared was 2. So this is probably about 4.1.
See that?
Thank you, Josh.
Man.
Are you using my dick?